Hello everyone. Welcome to our session on privacy first, building LLM-powered web apps with client-side WebAssembly. My name is Saiyam Pathak. I'm working as principal developer advocate at Loft Labs, and I'm joined by.
I'm Shivay, so I work as a developer relations engineer or developer evangelist at Couchbase, and I'm also a core contributor to the Wasm project.
Awesome. So let's get things started. Set the context first with the AI ecosystem. So it's basically not something which is very new. So if you have been searching on Google, when you type what is, then it tries to give you some search results which are there. So means the prediction of what comes next as the word or what you might be searching based on your geographical location and whatnot stuff. It has already been providing you certain stuff. And booking Airbnbs, watching movies, getting recommendations for that, everything in our day-to-day lives was already kind of having this. But for everyone, it got mainstream. For everyone building application around AI, the whole funding ecosystem around AI boomed when ChatGPT came into picture, because it kind of became a next revolution where a person, whether in tech or in non-tech, everyone just knows about ChatGPT or AI, which is a very big thing. So that's how the kind of I term it as a the AI revolution that started after. But before that, when the GPT model was there and it was not for the public, the researchers were pretty excited at that particular point of time, because they knew the potential that it would be having. So right now, what's the current state? Current state is that, I mean, we are not sleeping. Current state is that today, if we kind of go to sleep and we wake up in the morning, we wake up to reality. There is a new model out there. So that's how the current state is. Like it's the LLMs or the models which are coming is at a much, much faster pace than anyone anticipated in the past. So you can see pre-2022 till 2023, you can count them. But 2023 till date, it's very difficult to even count them. And yeah, we all know some of the cool ones out there that gets hyped up on X platform or whatever that is. Like you have Llama, you have DeepSeek, you have Falcon. All these are the popular models. But there are a lot of other models targeted for specific tasks like image, stable diffusion, research, deep research, and all that stuff. So that's the current state, which is very crazy out there in the AI ecosystem. And also how you usually use, like today, most common way of consuming the generative AI that we call is via the web. So we have all these web applications, and we are the end users, use these web applications to do our day-to-day tasks and interact with that. How do we build these applications? Building these applications is easy, right? Because you have APIs. You can call those APIs with whatever programming language of your choice. So you can see you have JavaScript, you can just import and give the model name GPT-4, or you can have Python and you can give DeepSeek, whatever that is. You will be able to connect to the model and get the response. So like a user writes the application and goes to the model, and the response comes back in. But there is a lot happening in that particular space, in both the spaces. One, writing the application. Two, how the model is kind of doing. So how the model is doing, we'll talk a bit later. Let's talk about the application first. And also, what about privacy? Because the talk is about that, we have to talk about it, right? So what about privacy? Since we are calling these models, which are available online, that are very powerful, that solves a particular task, gives you a lot of good information, sometimes hallucinates. Hallucination is also just a model error, because everything is based on matrix multiplication and mathematics. There's no, like, human only makes hallucinations. So it's a user that passes data, files, images, sensitive information, but is it suitable for very critical industries? Is it suitable for healthcare, where you have patients, the data is there, very critical, military secrets? Yes, it might solve some of the problems in that space, but is it worth it compromising the military secrets over there and sensitive information, secrets and stuff? Why I can say that this is scary? Because of all these news headlines that are there. So you can see Samsung meeting notes and source code were leaked with ChatGPT. ChatGPT was offline because people were able to see their each other's chats. Grok for misusing the AI data. DeepSeek, since the time it has come, people have been saying that it uses anything that you just give it for retraining. And it happens, right? Nobody tells you that whatever you are sending, the data you are sending, they would not use it to improve the model or improve what they are predicting. So this is concerning. So one thing is the privacy issue of using all these available things. The next thing is the cost. So what about the costs which are there? We should not forget about the cost, because the output per million token price for every model is like, it's very expensive when you do it from the APIs. So cost is one challenge, and then how to deploy it in production, how to deploy it on existing infrastructure like Kubernetes and stuff. It's a whole new story with its own set of best practices and stuff. But we'll come back later to that. But how to build these, the question now is how we can build this, because right now we are focusing on that application layer. How we can build these web apps in a secure and cost-effective way. So what to do is, basically there is a project called Ollama. There are a lot of models on Hugging Face. So you can have Ollama to get up and running with models, and you can have your own server, your own model deployed over there with your own trust, privacy, that nothing is going on through the cloud APIs which are there. And this acts as a back-end web service that you can call within your application. So how to do it natively in the browser, like how we can do all of these in the browser. Let's take a step back and let's understand three things over here. One is WebGL. So WebGL is basically a graphical abstraction layer on top of the GPU, and that graphical language will then do the computation or the calculations on the GPU. It works. It's a bit slower because it's abstraction layer on top of GPU. It doesn't do it directly. So for not optimized for parallel compute tasks in the AI ecosystem. Then is obviously WebAssembly, for what everyone is here in this particular conference. So let's try to understand its flow, but the only thing here is that this works only on the CPU architecture if you only use WebAssembly. So it's a performance-wise, it's a bit lesser than the WebGL, but the execution flow is interesting. So there are a few steps here, like if you see, there is a model preparation. So you can have, there's a framework called TensorFlow.js that Shivay will be talking in a bit detail later on. So you have these frameworks that convert these trained models to the browser compatible format, and then they are quantized. So because you have these billion parameters, 120 GB, 150 GB models, you cannot run those in the browser. So you need something how we can quantize it so that you are able to run these in the browsers. So that's how the models are quantized. And then there is the backend initialization for the WebAssembly. Using again the TensorFlow.js and stuff, and then comes the inference phase where the browser captures the data using the DOM and using all the stuff over there, converts that into the JS and do the process, and then again it is processed using the WebAssembly module. So the module executes the compiled model operations directly on the CPU. So this one is on the CPU itself. Interestingly, we have something which is called Web GPU. So when you combine WebAssembly with Web GPU, this becomes powerful. So you can Web GPU is kind of a successor, or you can say now most widely used than WebGL, because it runs directly. It is able to do the parallel compute on the GPUs itself. So Web GPU and WebAssembly becomes a very good combination, where WebAssembly handles the logic data, the pre-processing, and Web GPU provides the lower level GPU access for parallel computing. So WebAssembly will be pre-processing the data. Web GPU is executing the compute for ML inference, and the results are then rendered via the WebGL canvas. So this combination is pretty interesting for heavy kind of applications, like if you have the applications where you are having a camera, you are inputting images, or you are continuously seeing from the camera, taking the frames and analyzing it on the fly. So this works really well in that high performance, giving you the high performance output. And also it opens up new possibilities of doing WebAssembly at the edge. But we have so many things which are there. So we have we have WebGL, we have WebAssembly, we know the privacy and the cost things, that those two problems which are there. There are so many devices which are there. You have CPU only, you have GPU. So how to select from a particular backend on a user's device? So let's try to understand in a bit deeper way on how it works.
Yeah, so as Saim kind of mentioned that we are talking about having these different type of backends. And when we say a backend, it's not like a server, right? We are talking about the supported backends that are running inside of your browser. So we saw that we have the support from WebGL, WebAssembly, and the combination of WebAssembly and WebGPU. Now, in order to automatically identify that what is the type of device backend that should be chosen based on what environment your code is being run on, based on the user, because you might have a user using the application on an iPad, or someone might have an HP laptop that's 10 years old, or someone might have the latest Mac. So there you can leverage this browser spec, which is the Web Neural Network API, that automatically is able to select the type of backend that is the most compatible, so that you as the user don't have to manually change that backend. Now, of course, when you are writing your application logic, you should include the capability to select these different type of backends, such that whatever model that you're running, usually it's not just a magic that your machine learning model will directly work in the browser. There is a process that actually you have to convert the existing model that might be written in Python with transformers. You need to transform that and make it compatible to run inside of the browser. And usually how that happens is that whatever application code that you have written, you'll need to write custom ops. So these are machine learning operations that take place, whether it could be the convolutional or mult, because ultimately whatever kind of operations are happening in your machine learning background, these are all mathematical operations. So we need to write custom ops supported for WebGPU, WebAssembly. So all of that can be handled with the help of the Web Neural Network API. And if you look at the overall architecture, so the entire premise is that whether you have a model that's coming from PyTorch or TensorFlow or even Onyx-based models, all of them will be supported with the help of the WebNN API. And whether you use a backend which is supported with WebGPU, with WebAssembly, or depending on what type of device architecture you're using, because an Android device will use something else. Mostly on iOS, you have Metal. Then, of course, if you're using Linux, you'll be using OpenVINO. So depending on the type of application or the platform on which you're running it, it will automatically be able to select it. And of course, because we are going to be using, if you're using a very large model, we'll need some sort of hardware accelerator. So in that case, you could use either CPU, GPU, or for that matter, if there are some really hyper-specialized processing unit like such as a TPU, then even those could also come into picture. But you, as the end user developing these applications, don't have to worry when it comes to choosing the right type of model. Now, of course, we spoke about TensorFlow.js. Now, I didn't want to have a dedicated slide on that because it is kind of in a maintenance mode now. There is no active development going on when it comes to TensorFlow.js. I mean, there are still a lot of AI models that you can still run. It's still supported. A lot of companies like Adobe, and then a lot of startups are also actually using TensorFlow.js in production. So, for example, this Adobe Photoshop Web uses a lot of machine learning models to do real-time editing of images directly into the browser. Or if you might have probably used Google Meet, the virtual background filter is using the MediaPipe API. So you're seeing that these are already in production, serving millions and potentially billions of users throughout the entire web. But the natural progression or the natural transformation of the TensorFlow.js library was with transformers, which is the biggest open source library today for the web. It's, of course, built on top or based on top of the of course, a lot of us might have heard of the transformers library. So in this case, what happens is that whenever there is a new model that has to be ported to the web, there will be a machine learning model that's written in Python. It will be first converted into the Onyx format. And then the Onyx format has bindings with WebAssembly and WebGPU that allows you to execute that particular code inside of your JavaScript application. So the transformers.js is definitely the most capable library that is out there that all of you can also use. In fact, I think I was just speaking with the original author of this particular library called Joshua, and he said that there are over million plus downloads happening on a weekly basis right now, and a lot of companies are also using this particular library in production right now. So one of the key things I wanted to show was, of course, this particular example will be having a lot of demos as well. I'll show the main demonstration when we talk about LLMs, but before that, I wanted to show one more additional demo that I was already running even you without realizing. So this demo was with the help of Whisper model. How many of you have heard of the Whisper model? So it's a open source model that was released by OpenAI. Yes, OpenAI does release some of the open source models, but it allows you to do real-time transcription of your audio. And it's actually hands-on one of the best models that is available today in the market. So in this case, when you compile it or when you combine it with transformers.js, what you do is that you load, or you have, of course, taken a base or a base Whisper model, and you've converted into the Onyx format with the help of the transformer.js model. Now, what you'll do is that initially when you run this inside of your web application, you would download that model. Usually it's about 1 GB in size. Once you have downloaded it, we'll use a web worker that is actually doing the inference. Now, as I'm speaking, it will take the audio chunk by chunk, and in each and every chunk will be converted and will be transcribed by the Whisper model, and then it will load that into my web UI. So hopefully, if everything was working fine, I should have already been captured a lot of this particular thing, and you can probably see probably what happened was that my laptop crashed a little, but you could see that I was already running it when I had started this. So you can probably see we talk about developer relations when we had just kicked off our session. So again, I'm not saying it's 100% accurate, but because it is running a very small model. Our browser is very capable, but it cannot run like a 70 billion parameter model. And looks like the application crashed, which is okay. I mean, but you can still see that for those folks who were there at the beginning, you can probably see that, yes, it did a good job. It's just that I'm not sure how optimized it is. But this is how it basically looks like. So initially, you would load the model. It will take a few seconds to load it, and then we can start to actually do live transcription. So probably a demo. Hey, everyone. I'm joining in here with Saiyam, doing a live transcription demo with the help of the Whisper model. So you can see that it's wonderful, right? There's no backend. In fact, if I also turn off my internet, which I'll probably do it later, it is doing it. I'm not using a web service. I'm not paying OpenAI. I'm not sending this private information to anyone else. So that's the beauty of being able to run these type of models on the browser. But of course, we have a lot more nice demos coming up later. So don't get too excited, because then otherwise you'll lose your energy. But anyways, so of course, today's entire session was how can we run LLMs in the browser, right? Because today, all of these native models are great, but LLMs are a completely different beast because they are trained upon so much amount of data, and you'll probably see that they can be anywhere between 1 GB to 500 GB in size. A lot of these models, like the 4.0 model, or if you talk about even open source models like the DeepSeek model, you cannot just even run them on your hardware, on your laptop, because they have such huge amount of weight, right? So what do you do? Like, how can we run them in a cost-effective manner? Because we saw that if you want to have security, if you want to have privacy, how can we run them and execute them in the browser? So that's the most interesting part. So don't just leave yet. So of course, we spoke about LLMs, right? Essentially, when you take some input text and convert it into output text, what's happening behind the scenes? You're tokenizing your input and the output, and finally then converting it into the text. Now, behind the scenes, we are also, of course, using an AI model. So, of course, these LLMs are nothing but a series of more complex neural networks. Now, if we understand that, for example, if I'm giving the input as write an essay about a GPU and the LLM is providing us that output. Now, usually there will be a multiple different type of architectures or runtimes or model runtimes that are capable of being able to do so. Now, the ones that you are specifically seeing are the ones that allow the capability to run these LLMs directly into the browser. If we talk about non-browser environments, you have things like transformers, you have PyTorch, all of these different type, or Hugging Face, they allow you to run these particular LLMs in your Python environment. But when we talk about how they run exclusively in your browser, and we'll understand how that actually happens behind the scene in just a short while, but technically you'll run them with either Keras, with TensorFlow.js, or the Onyx format, which I showed you with the, the Whisper model, so that'll be using transformers.js. Or if you have your own LLM, for example, a Gemma 2 billion parameter model, you can use applications like MLC or MediaPipe that can convert that particular model format to be well suited for running it directly into the browser. So if we go a bit further into understanding this from an architecture perspective, so what's happening behind the scene is that we are using this framework called as MLC. It's an Apache project. What it basically does is that it takes your original code that you might have written in Python, and it will convert it into the Wasm and the web GPU binary. So you'll basically compile your original model code into WebAssembly binary, and the WebAssembly binary will then expose the set of web GPU APIs, because WebAssembly has that correlation or that bridge with web GPU, so that it can leverage those set of web GPU APIs for doing the more harder compute. Because as we know that WebAssembly can only do the compute on CPU. So when it comes to more of the internal mathematics that's going on behind an LLM, that will be taken care of with the help of the GPU. Now, of course, as Saiyam mentioned earlier, that you cannot just take a 70 billion parameter model and run it. Because if you think about it, like something like a Llama 2 model, even when you have like a 70 billion parameter model, that'll be 130 gigabytes in size. If you're taking, like, let's say, a 64-bit precision, which means that you will have to store 130 gigabytes in your browser, which is not feasible, right? So usually you'll employ a technique of converting it into a smaller format, which with the help of something that we call as quantization, which essentially means that the total number of bytes that you're giving to the model, we are reducing that precision. That means from 64, it will be like 4 bytes. Now, while that does lead to a reduction in your overall accuracy of the model, it's still decent enough that you can do a lot of basic tasks, such as summarization, text generation, that we'll see shortly, or even use it for applications like retrieval augmented generation. So in this case, what we are going to be doing is we are going to be using the MLC framework, where we will take the original model that you have taken, a quantized model, converted into WebAssembly and web GPU, and then we'll have that model available to us with the help of the APIs that are provided by MLC or MediaPipe that you can now start to use in your application. So here is an example. Of course, you can try out what we call as the web LLM. That's the framework that allows you to convert the model into that format. It's very easy. You start by creating the MLC engine inside of your web application, and then you define what model you're using. And you'll see that it has a OpenAI compliant architecture. So if you might have used something like chat.completions API, it's very similar, right? We are not changing the developer experience at all when it comes to interacting with these LLM-based applications. But of course, the magic is that this LLM is completely running in the browser thanks to web GPU and WebAssembly. And in fact, you can also bring your own model. So web LLM or MLC allows you to convert your own model. So if you don't want to use like a Gemma model, you can also use something like a Llama 2 model, Llama 3 model that's optimized to run in the browser. And MLC will help you to convert it into the format that runs in the browser, and you can execute it. Now, let's take a look inside of a real-life application, right? And I also just want to be ensure of the time. But let's go into this application. So I work at Couchbase. It's a vector, so it's a NoSQL company, but we also have vector search, right? So I do a lot of day in, day out work with RAG, or which is called as retrieval augmented generation, which means that if your LLM has not been trained upon some private data, you can still actually augment it with some external knowledge that usually comes from retrieving it with appropriate knowledge from the vector store. So in this case, the application is I'll upload a PDF document, and it will chunk the PDF document, generate embeddings, and store them directly inside of my browser. And then it will use the Gemma model to do the augmentation and generate the result. And then I'll also show you by also turning off my Wi-Fi that it actually is working. So in this case, I'll just upload a PDF document. In this case, I'll upload a document from my previous presentation that I gave a couple of weeks back. So in this case, what I did was that automatically I had a PDF reader or a JS PDF reader that automatically extracted all of the text from my PDF document. Another thing I want to show is I'll probably retry this because I want to show you what's going on behind the scenes, because that's like one of the key things to basically cover. So I'll again let the model load, and I'll choose that file again. Now what you're going to be seeing is that it says added 220 entries in 3 chunks, because I have a on-device vector database that's basically running here that's going to be using this Zenova all-mini-L6 embedding model, and that's also completely running in the browser. So it's not only extracting all of the text, converting it into the embeddings, and storing it inside of the indexed DB that's a local DB that's running inside of the browser. Now, once I've done that, I can go ahead and ask a question about this particular PDF. So let's say I ask it, what is flight? Which is the context of this particular document. So it says, according to the document, flight is a tool. Okay, I mean, not probably a very good answer, but we can probably ask it, what is prompt engineering, right? Or probably if the audience wants to ask a question, we can do like a live demo. Like we have a bunch of resources over here if you want to ask some question related to the PDF. Probably let's go to a random section and try that, where we have I think a decent amount of, any suggestions? Anyone wants to? We can probably ask it, let's see, probably what is prompt tuning? We can probably ask it, what is prompt engineering?
Yeah.
Yeah? Okay. Let's ask it, what is prompt engineering? So, I mean, it gives you the idea, and what you're also seeing is that it's giving you the sources. So the idea behind RAG is that when we perform the vector search, it finds the most relevant set of, or semantically relevant set of documents that are there. So in this case, I have the source, and it automatically goes to that particular source. So in this case, because it performed the vector search and it also generated the result, now I can also turn off the internet, and you'll see that it will still execute. So I can ask it a new question. So I can probably ask it again, what is flight, right? So let's see. Yeah, perfect. So this time it says that it's used to refer to a system for machine learning model orchestration. And you can see that it is completely running in an offline manner. Because the reason behind that is, if you look at the network tab, if I go over here and look at my network tab and probably reload the model, you'll see that there is this ORT Wasm SIMD, right? So that's the actual WebAssembly module for my LLM. And when I start to execute, it uses the web GPU behind the scenes to do the execution and give you the inference that's happening, again, in a completely offline manner. So that's one of the key aspects. And if I go directly to my code base, I can probably show you the magic that's happening over here. So by the way, like this particular code base will be open sourced. So if you want to have discussion, I know we are running slightly out of time, but I would be happy to share the code base with you. But trust me, like it's working, as you saw, right? So I'll go and turn my internet back up again. That was a quick thing about the web GPU and how you use it for doing on-device inference. Now, another great thing is that a lot of the browsers are coming up with their own set of API and tooling that allows you to do LLM inferencing. So Chrome, they last year announced the Gemini Nano that can run completely in your browser. And in fact, they provide a set of different APIs that you can use, like doing real-time translation directly in your browser, prompt APIs. So this works well if you want to use the native web APIs and also then combine them very well with the APIs that are provided to you with the help of these models. In fact, like Mozilla also just a couple of months back has added support for transformers.js to run AI directly inside of the extensions within Mozilla Firefox. In fact, you can also run AI agents because you can run LLMs. So we don't have enough time, but I'll recommend, this was supposed to be a demo where Jason Mays, who is one of the web AI leads at Google, he built this agentic application where he's using tool calling to generate a Spotify playlist on the fly based on your mood. So you define your mood to the application, and it runs it completely again inside of your browser. You just provide your Spotify API key, and it does that for you. So probably, Saiyam, if you want to talk about, are we there yet?
Yeah, so yeah, it's basically we have models, but we need to quantize them if we want to run in the browsers. So smaller, more efficient models with similar results. Hardware is something that obviously we want it to be run in a private mode, the privacy first, and which is where affordable hardware will continue to improve. So we'll have more and more chips. We have more and more announcements from NVIDIA and different organizations on how they are coming up with better GPUs, better accelerators within the hardware, day-to-day hardware that you are using. And then access to AI-optimized hardware, WebNN, like he was showing in one of the diagrams where you have WebNN that automatically does, whether you are using Web GPU, WebAssembly combination, and stuff like that. And yeah, AI is evolving, hardware is evolving, and we'll see more and more of these things. And I think the idea of this particular Wasm IO is, are we there yet? Like, is WebAssembly ready for production? The first session, if you remember from day one, is it ready for production? So I think the application that was shown makes sense because it's the application that matters. Behind the scenes, yes, it is running WebAssembly and it is using that architectures and stuff, which is good. That's why it is behaving in that manner. But for the end users, for selling, for the enterprises, it's the application that needs to be sold rather than the technology now, because now everyone is aware that yes, WebAssembly is a solid technology, it works, and we have the practitioners in the enterprises who are experts enough to use WebAssembly in their organization. So AI in the browsers, yeah, the benefits are already there, like no drivers, no installs, data stays on the client, and scales indefinitely.
Yeah, so I mean, you saw that with my code, I didn't have to pay OpenAI. I didn't have to worry about my privacy. I didn't have to, think about privacy or latency at all because everything was running inside of the browser. So that is why, like, I have been very bullish about AI capabilities running in the browser ever since 2020 when I first took part in my hackathon, and I literally like won 15 hackathons straight in a row because I was the only one who was doing this, and I understood that. And I think like we'll see more and more applications that will take advantage of being able to run in-device or on-device AI. And I think like WebAssembly is a huge proponent to that. And hopefully by next year, we'll have many more examples of production use cases for WebAssembly. Because we always question that, is WebAssembly ready? I think the browser is the perfect example because WebAssembly started with the browser. And even today, it still, of course, like Saiyam comes from a vCluster background, so he deals with a lot of Kubernetes. You can probably have a chat with him on how to do that more efficiently with vCluster, running AI workloads, WebAssembly workloads over there. I come with a lot of database background, and you can do a lot of stuff with that. But the thing that excites me more is definitely the browser. So with that in mind, I think we'll conclude our presentation. But if there are any questions, would love to hear. And yes, I'll be sticking around to discuss more about the code base because I know that we ran slightly over time, but I'll be more than happy to show you how everything is working behind the scenes as well. Thank you so much.
Thank you.